What's poppin', dogs? Mr. Allen here with some writing of trigonometric equations here, given the graph in these videos. And we got two different examples in this video. I'm gonna do another one with two examples as well. So first thing I like to do here is identify some of the key features. How about our amplitude? And I'm gonna actually draw in my midline first. I always like to draw in my midline. It helps organize some things. I can see where the points are on it or off it, and also see my midline nice and easy. So there is my wonderful midline right there. So how high above, or how far above and how far below am I going from that midline? Well, since the y-axis there is not marked out, we're just going to assume it's going by ones. So 3 is my amplitude here. What's my period? Well, I can tell what my period is either going from high point to high point or midline to midline. And here's what I'm going to do. I'm going to go with green is going to be my common color, and then blue and how about maybe orange will be my other colors here. So for sine, all right, so we're going to do sine and blue here. Sine starts on the midline. So I'm looking at like this point right here. Okay, it's kind of a terrible circle. So that point right there, that'll be a sine graph start. So how long does it take for a sine graph here to repeat? Well, that would be, boom, right there. It ends at pi. So my period here is pi for my sine graph. Is that going to be the same thing as my cosine graph? Let's see here. How about I go with, actually, I'll do yellow for this, okay? So if I circle up here in yellow, why did I pick above? Well, cosine either starts above the midline or below the midline. So for this one, the cosine is going to have to do like some kind of a phase shift, right, so that I can be above the midline. So if I do my whole little, follow this along, whee, it ends right over there. So high point to high point would be cosine, or midline to midline, but you got to make sure that you pass through, right? I'm not midline to midline there. It's actually the next point right there, okay? So with sine, it's sometimes a little trickier to see because you got to pass through the midline once, but cosine is just high point to high point or low point to low point. In any event, my period here, it looks like it's repeating every pi, okay? So we'll go ahead and put pi for my period. So what's my period multiplier going to be? It's going to be the same for each equation, right? When I do the green, that means it's for both equations. So for my period here, if it's pi, my multiplier, I would do a little 2 pi divided by pi, all right? And that's going to cancel out, giving me 2. That's the period multiplier that goes in the equation. How about my midline? Midline's the same for both of them as well, right? It's y equals -1. Cool. And then how about my phase shift? This is where things change pending the equation that we're working with here. Well, for sine, which I did in light blue, sine, no phase shift. So I'll say sine, none. And then how about cosine? Cosine's in yellow. I'll circle that actually. Cosine, I got to go to the right by how much? Well, this right here in between the 0 and pi over 2, I'm going to the right pi over 4. So we'll say cosine is right pi over 4. All right, there we go. So we got all of our information that we need here. Let's write the equations. So if sine's in blue, and it starts on the midline, and it's on that y-axis, no phase shift needed, I'm going to have y equals 3 for my amplitude, sine, then I have my period multiplier, which we know is 2, thanks to this guy right here, and there's no phase shift, so it's just going to be 2 theta, and then I had to shift down 1, so -1 for my midline. There we go. That's a beautiful, wonderful sine function or sine equation. How about cosine? Well, a lot of these parts are going to be the same. The amplitude is going to be the same here. It's going to be 3 cosine, but here I have my phase shift of pi over 4 to the right. So I'm going to do 2 parentheses. Make sure you put an extra set of parentheses here. Otherwise, the phase shift will be incorrect. It's got to be in this factored form to be correct. So I'm going to have theta. And then we have, since we're going to the right pi over 4, we're going to do minus pi over 4, close, close, -1. So you'll see the amplitude, the period multiplier, and my midline. Those 3 things are the same. It is the phase shift that can change or potentially having a negative, okay? So here's a what-if scenario, and I'll do this in orange. What if I decided for the cosine function I wanted to just shift left, and I started down here? Well, now my one period would follow along that orange line. It's a little bit messy to see right now. But my period's still the same. My amplitude's still the same. But I'm starting negative. So instead, we're going to have y equals -3 cosine to, my period's still the same, so the multiplier is the same, theta, but I'm going to the left pi over 4, so it'll be plus pi over 4, close, close, minus 1, and there we go, we have another version of our cosine function. So there are actually an infinite number of correct answers for these problems, but we're usually going to stay within like the common few right there. If I can avoid a phase shift, I'm going to avoid a phase shift like the sine one there. There's no reason to phase shift for sine, so I'm just going to leave it right there at 0. Cool? Awesome. Wonderful. Any questions? Any questions? Okay, no, we're going to move on. Let's try the next one here. So I will keep my, my sine in light blue and my cosine in yellow. Yep, yellow. And we'll do our common color in green here. So midline, let's get that guy in there first. It looks like our midline is here at y equals positive 1 this time. And then amplitude. This one, the amplitude is actually 3 again. All right, I'm 3 above right here. Woo, 3 above, 3 below. Cool. And then how about the period? Interesting. Well, you can really figure out the period, as we already just found, from either our sine graph or our cosine graph. This one looks just like a sine graph that starts way the heck over here, right? And my sine graph is just going to follow along this whole thing. It's going to take 4 pi to complete that entire thing. So although I only see the sine graph on here, it does continue on forever, the period is going to be 4 pi for both, okay? Which means I need to figure out my multiplier. Let me actually make that a little smaller so I have some room. 4 pi. So then my multiplier, I'm going to take 2 pi divided by the period, which is 4 pi. Pi's cancel. I simplify down to 1/2. So the 1/2 is what you're going to see in the equation. Midline is y equals positive 1. And then phase shift. Well, it depends on which one we're talking about. Since we said sine there, we were shifting to the left 2 pi. So sine is left 2 pi. And how about cosine? Well, I guess I could start the cosine graph up here, right? And then that'll drop down, and then it would just come up, and it would end up way the heck over there, right? A little bit further than where this thing actually can be. Like I'd be another little bit further here. It'd be more like, woo, somewhere over here. So that's where, and then it'd be coming back down. Yay. So that's my full cosine one right there. Still, it's a period of 2 pi like we talked about. But all we're really worried about now is that phase shift of the cosine graph. So cosine, there we go, cosine, that is going to be left by pi. Left pi. Cool. I think we got enough information to write our equations here. So for the blue one, sine, we have an amplitude, so we got y equals 3 sine. And it starts by going up, so it's positive 3, right? It starts on the midline. If it goes up, it's positive. If it goes down, it's negative. So my multiplier, we said, is 1/2. We figured that one out already. It's the same for both. And then I have, let's see here, theta. Do I have a phase shift? Yes. And it's, theta. And we're going left 2 pi, so plus 2 pi, close, close. And then we went up 1 for our midline, so plus 1. There's a sine graph, or sine equation. How about cosine? A lot of the stuff's going to be the same, right? Y equals 3 cosine. And then I have the 1/2 still. And then we have theta. What's our shift? Our shift is to the left pi, so plus pi. Close, close, plus 1. There we go. That's it, man. That's it. We got our 2 equations. Again, you could have started them in different spots. If I wanted, actually, I think, now that we look at it, let's do like one last thing here with our sine graph. What if I just wanted to start right here, right? No phase shift. I could do that because my sine graph would then look like a full period would be like, wee, right? And then back to the midline right here. So that'd be my full sine graph. So I could start it without a phase shift. But what would change? I'd have a negative out front because it starts going down first. So if you're like, hey, could I have done this? Y equals negative 3 sine of 1/2 theta plus 1, that is absolutely correct. That would be a totally correct answer right there. Still have the amplitude of 3, still have the period of 4, have the midline of 1. We just didn't shift, but we started by going down, and that's what the negative out front does. So again, a lot of different options here, which does make it kind of confusing, but hopefully that helps. Just make sure you got a few of the things that are all the same, And then your only difference that needs to happen there is either a phase shift or perhaps a reflection and negative out in front. That's about it. All right, hope that helps you guys. I'm gonna make one more video on this stuff here if you need a little bit more. There is gonna be another one coming, so stay tuned and stay dope.